we're going to talk about variation functions today. Chapter 8 stuff. This section is pretty easy, and 8.2 is pretty easy. We get to 8.3 and 4, it gets a little bit more difficult. We got 3 weeks left this 9 weeks, and we'll be 3/4 of the way done. It's going fast. And this last 9 weeks will go really fast. All right, so we're going to talk about direct, inverse, joint, and combined variations. Okay? The combined one is just when you have a direct and inverse one in the same problem. Okay, but this is pretty easy stuff today. All right, so when we have a direct variation, we're going to be doing multiplication. When we have a joint variation, we'll be doing two things. It'll be multiplication and division. Inverse is going to be division. I said that wrong. Joint variation is when you multiply, also like direct, but there's at least two things that you'll multiply in a joint variation. Inverse is division. A combined variation, you'll have either joint and inverse or direct and inverse, where you'll have multiplication and division in it. Constant of variation is in every stinking problem. There's going to be the letter K. You will not read, when you read the problem, you will not, they won't tell you that K is in there. You're supposed to remember that it's in there. When you see that word varies directly or varies inversely, sometimes we'll say is directly proportional to or is inversely proportional to. You have to put the letter K in the equation, right? Every time you're going to have to put the letter K in there.
Sorry, my mom texted me.
Tell your mom she's in trouble. All right. So in chapter 2, we talked about different types of linear functions. And one special type of linear function is called direct variation. A direct variation is a relationship between two variables that can be written in the form y equals k times x. K will never be 0. In this relationship, k is the constant of variation. All right, so for the equation y equals k times x, y varies directly as x. So when you see that, as when something varies directly as something else, all right, the first thing you see, you'll write equals k, when you see the word varies, and then directly means times. So that's why it's k times x. Okay? And when it's a direct variation, as one of the variables gets bigger, the other one gets bigger. As one gets smaller, the other gets smaller. Okay? They go together. All right, so again, direct variation, I know it's kind of small. Well, that's not what I wanted. All right, when they say y varies directly as x, that's the equation. Y equals k, the constant of variation, times x. All right. A direct variation equation is a linear equation in the form y equals mx plus b, where b is going to be 0. And then the k is your slope. So the graph of a direct variation always passes through the origin. What's the origin again? 0, 0, right? Where the x and y axis intersect, right, John? You're zoned out already, man. All right, so here's, again, I'm not going to worry about graphing. We know how to graph linear equations and stuff, right? So we're just going to solve these. When it says y varies directly as x, I'm going to write y equals k times x. Then they're going to give us some information, right? Y equals 27 when x is 6, right? And graph the direct variation function. All right, so we'll just substitute in. All right, y varies directly as x, y equals k times x. Y is 27, x is 6, so we'll put those in. And then we're going to solve for k. So how do I solve for k? Divide by 6. We all know that, right, Kennedy? All right, we're going to take the 6 over to the other side. So K is 27 over 6, which reduces to what, 4.5? So the constant of variation in that problem would have been 4.5. Okay, so some of the problems I'm just going to ask you to solve for K. You following along with me, Dave? That's what I'm asking. You following along with me? Okay, good. Just check it. All right, sometimes what they'll do, they'll say, then they'll put a second part to this problem. They'll say, find y when x is, 7. And then what you have to do is put 4.5 in for the k, put 7 in for x, multiply them, and then that'll give you your y. So there's like 2 parts to these sometimes, a lot of the times. Again, we're not worrying about graphing those. All right, if k is positive in a direct variation, the value of y increases as the value of x increases. All right, if it was negative, then it would decrease it. That's the one. They go together. All right. So y varies directly as x. So what do I write right away? Y equals kx, right? So then it says y is 6.5 when x is 13. It says write and graph the direct variation. Again, I'm not going to worry about you graphing it. Just be able to find k. What do I do? Divide. So what's k equal? I heard somebody say it, I think. 1/2, did somebody say it? Or 0.5? Pretty easy so far, isn't it? Again, there's the graph. We're not worried about that. All right, so the cost of item in euros, so they use E for euros, varies directly. So I see that varies directly, so I'm going to write E equals K as the cost of the items in dollars D, so K times D. All right, so this is a 2-parter. I don't know why all those spaces are in there, but that's all right. Okay, so find K, so it goes E equals K times D. I don't know why my type size gets all messed up either. All right, so E equals K times D. Again, it says varies directly. So when I see the word varies, K directly times. All right, so I'm going to substitute 3.85 in for E and 5 in for D to solve for K. So divide both sides by 5, and we get K, the constant of variation is 0.77 for this problem. All right, and the second part is find D when E is 10, right? So this time I'm going to put 10 in for E and 0.77 in for K, and then I'm going to solve for D. That's the second part. All right, and just divide by 0.77, and you get $12.99. So 10 euros is about $13 in this problem. Okay. So there was a second part to this. So make sure you find K, and then you can answer the question. Part 2. Does that make sense? All right. The perimeter P of a regular dodecagon. What's a dodecagon? Is that 12 sides? Varies directly as the side length S. P is 18 inches when S is 1.5 inches. Find S when P is 75 inches. Okay. All right. So again, varies directly. So P equals K times S is my equation. Right? That K shows up. every time. Every time. Okay? So I'm putting 18 in for P and 1.5 in for S. So I can solve for K. And I get 12 for K. And then when P is 75, what's S? So I'm going to put 75 there. I'm going to put 12 in for K for part 2, and then solve for S. So again, how do I move the 12? Divide again. And the side length would be 6.25. What's regular mean? Regular dodecagon. Yeah, all sides are equal, right? When they say regular polygons, all the sides are equal. I think all the angles are too, right? I haven't taught geometry forever. All right. So direct variation, multiplication. All right. A joint variation is a relationship among 3 variables that can be written in the form y equals k xz. K again is the constant of variation. For that equation, y equals k times x times z. Y varies jointly as x and z. Again, sometimes they'll say directly proportional to or inversely. They'll never say jointly proportional. So I say varies jointly for a joint one. What's that? Could get rid of that. So the volume V of a cone varies. When I see that word varies, what must I remember to put in my equation? K. Right? As the area of the base, capital B, and the height, H. Right? So that's V equals K times capital B times H. There's at least 2 things when it's joint. Most of the time it's just 2. But, all right, so there's our volume is K, constant variation, times the area of the base, times the height. All right? So V is 12, capital B is 9, H is 4, and then I can solve for K. That's the first part. 9 times 4 is 36. What do I do with that 36? Divide it over. And 12 divided by 36 is 1/3. So my constant of variation is 1/3. So that's your formula for volume of a cone. You remember from geometry, volume equals 1/3 times B times H. In pyramids, I think, were 1/3 as well. All right, and then part 2 is there on the right. All right. So when the volume's 24, I'm going to substitute 1/3 in for K. They want us to find, again, that should have been a capital B. I don't know. It's messed up. I need to fix it. Capital B, and then H was 9. So we substitute 1/3 for K, 9 in for H, 24 for volume. 1/3 of 9 is 3. What do I do with the 3? Divided, right? So what's 24 divided by 3? 8. So the area of the base would have been 8 square feet in this problem. Volume's in cubic units, right? That's cubic feet. Because there's 3 dimensions to volume, right? Making sense? So direct variations and joint variations are multiplication. All right? Here's another joint variation. The lateral surface area, capital L, of a cone varies jointly as the area of the base, radius, R, and the slant height, L, small l. All right? So capital L equals varies jointly, so K times R little l. We got to find K. all right? Radius was 3.5, when the lateral surface area was 63 square meters, and the lateral slant height, whatever, is 18. So multiply those and divide it over. 3.5 times 18 is 63. 63 divided by 63 is 1. All right? So find the radius to the nearest tenth when capital L is 8 square meters and small l is 5 meters. So I'm going to substitute 1 in for k this time. 1 RL. Capital L was 8, little l was 5, so the radius is 8/5, which is 1.6 as a decimal. Making sense? All right, so direct, joint, multiplication, don't forget your K. All right. A third type of variation describes a situation as one quantity increases, the other decreases. For example, the table shows that the time needed to drive 600 miles decreases as the speed increases, right? So if you gotta go 600 miles and go 30 miles an hour, it's gonna take you a long time, right? 20 hours, but if you go 50 miles an hour, speed got faster, your time got smaller. This is an inverse variation. An inverse variation is a relationship between two variables, x and y, that can be written in the form y equals k divided by x. Again, k will never be 0. And then y varies inversely as x means y equals k divided by x. Inverse division, okay? Everything else was the same, all right? Given y varies inversely as x, that means y equals k divided by x. And then y is 4 when x is 5. Again, we're not going to worry about graphing. So what do I do with the 5 to move it over? Multiply. So we get 20 as our constant of variation. So our formula is y equals 20 over x. And then you could graph it if you had to, but again, I'm not worried about graphing. I know you guys can do that. All right. Another, y varies inversely, so y equals k divided by x. So 4 equals k divided by 10. What do I do with the 10? Multiply, so k is 40. So the equation would be y equals 40 divided by x, and then part 2 would come after that. Making sense? All right, so again, and then, those look a little different, those graphs, all right? But I'm not worried about the graphic stuff. All right, so the time t needed to complete a certain race varies inversely. So t equals k divided by the average speed s. Okay? So there's my t for time, k over s. Then the speed, make sure you put the right number in the right spot. The speed, the s is 8.82. The time is 2.97. All right, so 2.97 in for t, 8.82 in for s. Multiply those to get to k, 26.19 or 26.2, let's say. It says, what is the average speed of a runner who completes the race in 3.5 hours? All right, so I'm going to put 26.2 in for k, and I'm going to put 3.5 in for t, and I can figure out the speed. All right, so what am I going to do to solve this now? How do I get that 7.5? That s is in the denominator, so how do I move it out of there? Got to multiply it, right? So this is, we got to slow down a little bit when you get to this type. All right. So then I have 3.5s equals 26.1954, right? So what do I end up doing to solve for s now? Yeah, divide by the 3.5. Okay? That's where that 7.48 comes from. Okay? So sometimes that's going to happen. But just realize what you got to do to solve for s or whatever it is. put that one in the denominator you're solving for. Move it out of the denominator first by divide or multiplying, and then whatever's with it, divide it over. Okay? All right. So T equals, it says inversely, K divided by V, right? All right, so 20 volunteers can build a house in 62 and a half working hours. So 62 and a half equals K over 20. Okay? Multiply by 20, both sides to get your K, 1250. So if 20 volunteers can build a house how many working hours would take 15 volunteers? Okay? So we put 1250 in for K, and we put 15 in for B, and we could find our time then. And all we have to do there is 1250 divided by 15. So 83 and a third, or 83.3 repeating. All right, making sense? So direct and joint, we're doing what? Multiplying. Inverse, we're dividing. What happens when they combine two together? Multiply and divide, right. All right, it says you can use algebra to rewrite variation functions in terms of K. All right, so when it's a direct variation, it's y equals K times X, but when you solve for K, you end up doing what? Dividing you got this, they call it a ratio, a constant ratio. If it's inverse, you're doing K divided by X, but when you solve for K, you're actually doing what? Multiplying, right? So notice that in direct variation, the ratio of the two quantities is constant. In inverse variation, the product of the two quantities is constant. So you're going to get a couple problems where they'll give you a table, and you got to figure out if it's direct or inverse, or neither, okay? So if it's direct, then what was it? Y divided by X, right? So is 8 divided by 6.5 the same as 4 divided by 13, the same as 0.5 divided by 1/4? Are all those the same? So you check that on your calculator, and if they are all the same, it's direct. If they're not all the same, then you do multiplication. So right there, I know it's not, right? You got to do y divided by x. So let's do the other. What's 6.5 times 8? And what's 4 times 13? And what's 104 times 0.5? So if the multiplication is the same with the two, then it's an inverse. So it's kind of backwards from what we've been saying. If they give it to you in this situation. Does that make sense what I'm saying? All right? So if you divide y by x and they're all the same, it's a direct variation. If you multiply y and x and it's the same, it's inverse. All right? What's 30 divided by 5? 48 divided by 8. 72 divided by 12. So that's a direct, right? Because the division, the product, the ratio, come on. Quit doing that to me. All right, so you're going to have a couple problems on homework that'll give that to you. We got to figure it out. All right, moving on to a combined variation. All right, so here's what it sounds. The change in temperature of an aluminum wire varies. All right, so varies, I know what has to be put in there. Okay, very good. Thanks for listening. All right. Varies inversely as its mass, so K divided M, and directly as the amount of the heat energy E. All right. So from that first, again, I don't know why this is all, but this is confusing the way it's all messed up. Temperature equals K. Inversely, the mass multiplied by the energy. You guys see how I got that? Usually they say direct first and then inverse, but this one said inverse first, then direct. Okay? So, the temperature of an aluminum wire with a mass of 0.1 rises 5 centimeters when 450 joules of heat energy are transferred to it. Right? So 450 is the temperature. All right? The mass is 0.1. Oh, you hear that? Oh, heat energy is the E. All right. So the 5 degrees, man, this is a pain. This one is 5. All right. You hate pain? All right. So let's make sure we put them in the right. This one, the way, this is kind of goofy the way the order they give us stuff. So we have to read it carefully. All right. So it says, again, the temperature of an aluminum wire with a mass rises 5 degrees. So the temperature is 5. Okay. All right. 450 joules of heat energy. And mass was 0.1, right? All right, the first thing I would do is what with the 0.1? Multiply, right? Which is just 0.5. You guys can do that part, right? Then divide by the 450, right? So what's 0.5 divided by 450? 0.5 divided by 450. Wow, 0.001 repeating. How much heat energy must be transferred to an aluminum wire with a mass to raise its temperature 20? So we got a 20, 0.001 times E, that's what I'm looking for, right? Over 0.2. All right? So, what do I do with the 0.2? Multiply. What is that, 4?
Oh my God.
Someone check me. I'm pretty sure that's 4.
Yeah, I think it's 4.
Isn't that 4?
Yeah, I'd say 4.
Thank you. All right. So 4 divided by that answer I got in my calculator, right? Oh. All right, so 4 divided by that answer, second negative. 3,600. That's a lot of, was that joule? Of heat energy? That's a lot. Pretty hot, isn't it? So that's a combination. It's going to have multiplication and division. All right? What do we got to remember? It's always in these?
Okay.
Okay, constant variation. So don't forget your K, friends. I want to see all of those little formulas that you make on your homework. Not just the answers.
My mom wrote it.
Did she? She checking up on you?